I'm very happy to welcome as the next speaker Lubaba Mawas. She's a project engineer with Nextracker based in Nextracker's Madrid office, I believe. And Lubaba will talk to us about something Shravan already briefly mentioned. It's about solving developer changes with bifacial optimized and terrain following trackers. Lubaba, the floor is yours.
Thank you. Thanks for the introduction, Michael, and thank you for the brief presentation that you gave us, Shravan. I'm gonna go ahead and share my screen. So welcome all to today's session. Today, we'll be talking about solving the developer challenges that Shravan introduced just earlier, and especially focusing on bifacial, on terrain following, and on the control softwares that we've got. Michael introduced me before, but I am Lubaba Mawas. I am a project engineer based in Madrid, and I am supporting the projects in the development and execution phase of the EMEA region. Before we start with the content, I want to present what is Nextracker. So Nextracker is the #1 solar leader of solar tracking products. We have shipped so far 58 gigawatts and sold around 60 gigawatt. Our parent company is Flex, so we are well established around the globe, and we have 8 global offices with more than 600 staff. An important thing to mention as well is that we have a diversified local supply chain. So we have, depending on where the project is, we will supply from one region on another, so that it minimize the risk of the projects, and we also make sure that we are all the time on time with the deliveries. So we have our solar trackers as our robust product line, but as I've said, we also have control systems such as TrueCapture and Nexnavigator that we will discuss later on. As mentioning, we have in the past 7 years, we've been the leaders in the industry, and we've been innovating a lot in terms of product of trackers and also in terms of optimization of the product and the software. So we have developed an independent, balanced, self-powered ROSE, which is our NX Horizon tracker. And then we also have the TrueCapture control system software and Nexnavigator for digital O&M. Lately, we've just launched our terrain following XTR product, and we've been doing several researches to make sure that we are all the time on top of innovation in terms of bifacial, extreme weather resiliency, etc. So before I get into the details of bifacial, I would like to highlight that our CEO, Dan Sugar, has always had a love affair with bifacial, and he always had this perception that the prices would come down. As Shravan was mentioning earlier, the prices now are quite, are affordable and are more cost competitive. So bifacial is a reality, and therefore the design of NX Horizon has always perceived bifacial trackers. So what are the enhancing features that best support bifacial trackers? So we use a high-rise rail that provides a 9mm space between the torque tubes and the cells of the panels. And that is basically allowing for more reflective light and less shading. We also use a 125mm round torque tube, and that is providing as well more reflective light than if you compare with a square or like with an octagonal torque tube. And we're also able to elevate those panels thanks or due to our mechanically balanced system. In the center image, you can see that we also leave some gaps above the pier and the bearing housings, where in a conventional tracker, usually the piers and the bearing houses would go under the panels and therefore create a backside shading. So, well, you know, when we leave this spacing, we're making sure that we are having more reflective lights to hit back up in the backside of the module, and therefore increase the energy yield. And the same happens with our drive system. So we leave, you know, a big gap around our drive system. Usually the drive system of conventional trackers live under the panels, and therefore we're also allowing for more reflective light. So yeah, all in all, we just want to make sure that we're optimizing the structure as much as possible to get as much gains as possible. We have done tremendous testing on our testing facility located in Silicon Valley, mounting top-tier modules such as Jinko, Longi, Canadian Solar, and we've also partnered with third parties and, you know, external labs to validate those results. One of like the biggest goals of this research was to establish a reliable PV-assist input to improve the bankability of the bifacial projections. So let's compare the results that we've got between what we've modeled in PVCs and what we've measured. I mean, the real data that we've got, and then compare it with the results from PVL. So as you can see, you know, this summary, you can see that the measured numbers exceeded by far what we've modeled. And therefore, you know, I mean, at the end, we will see how PVC sometimes most of the times is under predicting the gains that we can get from bifacial modules. So the top row in yellow color is the high albedo, and then the green is the low albedo, which is more representative of a natural and treated ground. And you can see in the high albedo situations, the model gains ranges from 9.8 to 13.4%. But the reality is that the gains exceeded those numbers. And for example, in January, we achieved around 14.5%. Now, in January, we have to mention that in winter months, typically the days, like the typical day in winter is an overcast day. So the more diffuse light, the more bifacial gains you would have. And similarly, PVL got similar results. Most of the data, the measured data that they got exceeded what the models on PVCs. And at the end, we want to make sure that we are validating PV-assist inputs so that our customers and developers can use them to have them in their business models. I want to mention that we've done this with several module manufacturers and also with large format modules. So we're 100% compatible with large format modules and throughout different seasons, winter and summer months. Sorry. Last January, I had the privilege to visit one of our flagship sites located in Dubai. It's a 1 gigawatt site located in the Dubai desert. It's called the MBR site, developed by Shua Energy, where Jinko is the module manufacturer. So when we were there, Shua Energy presented their results on energy yields, and the energy production was exceeded by far of what they expected. So it is a reality that with Nextracker, you know, Nextracker combined with partners like Jinko, we can improve the gains, the energy yield for our owners, and we're very proud of this. Now, let's dive into our control system software. As we were mentioning before, TrueCapture is self-adjusting tracker tracking control system that is basically enhancing or improving the production of the site or of the plant based on the site conditions. And when I refer to site conditions, I refer to two components. We have the row-to-row tracking, and then we have the diffuse light. So the row-to-row tracking, the standard backtracking algorithm in the industry assumes that the site is completely flat and that there is no slopes, while in the reality, the sites have slopes, there are install variances, there are undulations on sites, and the panels are not at the same height, right? So what TrueCapture does, it breaks the system-wise algorithm into row-to-row algorithm and position each tracker to optimize and enhance the energy. It can achieve up to 6%, usually is between 2 and 6%. And like even this seemingly flat site will have slope. So any type of sites in reality would benefit from TrueCapture. And then we also have the diffuse light tracking mode, which instead of the tracker like continue to track as if there was sun, in situations where we have scatter light or particles in the air, or like an isotropic situation, the trackers go to flat position so we can produce more energy inside. Now, it's not as primitive as like putting all the trackers in flat positions at 0 degree, but there is a bit of math and a bit of our intellectual property onto finding the right angle to get that energy enhancement. This is a typical day and as an example of what would be the perfect tandem by combining Bifacial and TrueCapture. As you can see, with TrueCapture row-to-row, we can get more energy production during the first hours of the day, and then the last hours in the evening. I think Shravan was also mentioning this, and then of course we can like seemingly, and we can get the same gains with bifacials as we were discussing before with the results that we've got. So at the end, like combining Nextracker, bifacial, and TrueCapture is just going to be the perfect tandem to get more production and get more energy yield on site. So as utility scale solar expands, into regions, we're seeing more and more complex sites. We're seeing very, very complex topographies, rolling hills, and it's just becoming, civil works are becoming a very important part of the project. The picture that you can see on your left side is the project that I was mentioning before, the MBR project in Dubai. And you can imagine, like just from the picture, imagine the amount of earthwork and grading that had to be done to have the trackers mounted. Usually, like nowadays, the civil works are ranging between 5 to 15% of the EPC contract, and they are becoming a big expense of the total project. So as a structure company, we want to make sure that we're minimizing that and that we're helping the developer times and successfully. So what we are suggesting is an XTR. Well, XTR is our product to overcome these hilly sites. So what the solution that we're providing is reducing the seal, reducing the grading. Now, this is not just gonna help you minimize your CapEx, but it also has many environmental benefits that we're gonna see in the next slides. So XTR is born from the various challenges that we oversee on the project that we are working on, right? So we have three main challenges that we're seeing now. I mean, first one is the complexity of the topography. Now we don't see anymore, you know, those perfect squared flat sites where installing or mounting PV is not complicated or extremely complicated. The projects that we're seeing lately are much more complicated, and the civil works are being a very delicate and important part of the project. The second challenge we're seeing is the permitting related to the environmental impact of doing grading. So as you know, for example, in Europe, there are many legislations coming up in regards to minimizing or in many times eliminating grading at all, and sometimes that is just putting the projects at risk, because if you can't do any grading work, I mean, the only solution that you have is just to use a structure that is following the terrain, and in this case is XTR. And then the third challenge that we identified in some markets like Australia or the US is the high cost of labor and grading. So, sorry, at the end in this rolling hill, crazy topography projects, the cost comes very expensive, and the capex is usually much higher than expected, and no one wants that, right? So therefore, the solution that we're providing is XTR, which is a tracker that is literally like following the terrain and minimizing those grading, if not eliminating them. If we really want to understand what is XTR, I think it's nice to compare with like our NX Horizon, or like with any conventional solar tracker. I like this picture because you can visualize it. So let's start from the left side. We have the NX Horizon. And basically, when you have like a complex topography or a complex topography on site, what you have to do is you have two options. You either do earth work, grade, you know, and have levelized surface, or you just have to increase the pier lengths and raise those trackers to maintain a uniform slope along the torque tubes and along the tracker. However, that, I mean, that is a solution. However, it becomes very, very expensive, and we want to avoid that. We want to help our customers to reduce the capex as much as possible. So with XTR, what we're doing is imposing a deflection in the tracker or in the torque tube and follow the terrain without having to grade or without having to increase the length in the piers. So yeah, like we're seeing that, of course, like the benefits of XTR are reducing the cost and grading, reducing the cost on seal, but there are also other associated benefits. We've talked about the environmental impact. We've talked about simplifying the permitting and minimizing the risk of the project. But for example, we also are optimizing the O&M services of the projects. So if you don't, for example, if you don't do grading, you're preserving your topsoil, and therefore you are minimizing and reducing the erosion on site, and then reducing by far the dust that would come on the panels. I mean, if like usually on sites where there is a lot of earth movement, a lot of dust end up being on the top of the panels along the life of the plant. So with preserving the topsoil, we also reducing the O&M, the cleaning of the panels on site. And at the end, we just want to make sure that we are being we're being not conservative, but like we're respecting the land that we are in. We are preserving the environment, and we are also reducing the cost on capex, on steel, and on grading. So this is a real project. This is a project in Portugal, and you can see the comparison between the standard NX Horizon and XTR. So, I mean, you can see like how big are the reductions on gradings. In this site, we've calculated around 65% reduction. It's one of like the craziest sites that I've ever seen in terms of orography, and it's very singular. However, like I say this is a singular project, but the reality is that the next projects that we're going to see and the projects of tomorrow are all going to be like this. As I said before, like we don't see the perfect flat sites anymore. So we need to find a solution to adapt to those singular topographies. Then this is another project which is already executed in the United States. It's a 250 megawatt project, and the savings here were around 2.3 million, which is a lot, but there are other projects where this number was exceeded. And as you can see in the picture, you can see how the tracker is following the hills or the undulations of the sides. You can see also how the tube is slightly, bending and following that undulation. We've launched XTR a few months ago internationally, but we have around 3 gigawatts already in operation. So the slide that I just showed is from a real project where we have XTR developed in, and we have around 4.6 gigawatts of contracted XTR projects. I mean, this is the reality that we're going to see in the next years of utility solar scales. And as Nextracker, we want to make sure that we're providing the right solution. And we believe that grading is becoming one of the main challenges, thus the launch of XTR around the globe. So hopefully we made it in time. I'm not sure if you have any questions or answers. I know that my colleagues have been answering you live, but yeah, happy to discuss more questions. We also have a web page with many resources with Bifacial, TrueCapture, and XTR. And if you have any question or any particular site that you would like to discuss, don't hesitate to email me or any of my colleagues.
Lubaba, thanks a lot. Great presentation. I think there's a big discussion going on the chat, and your Christian is already answering some. Maybe we can continue that. We're running a little bit behind time. Yeah, once again, thanks a lot for this presentation. I think it's really important what you're doing because, as you said, the sites are getting more difficult to access, but we're just at the beginning of solar. We've just installed a bit over 1 terawatt, but there's many terawatts to come. We will need a lot of space. People have to get used to blue fields if we really want to transition to renewables, and doing it in a way that is as sustainable as possible is really a must to take the local people with us. So once again, thanks for.
Thank you, Michael.